So this is what Scratch looks like. Hopefully it's not too daunting to those people who've never seen it before. Let's take it step by step, which is going to be kind of a recurring theme during these videos. So on the top left we have the stage area. This is where Scratch currently is sitting. Scratch is the name of the cat, in case you hadn't already worked that out for yourself. Underneath that we have the Sprites section. We'll go through the terminology afterwards. In the middle section we have all the various commands that you'll use to build up your programs. Next to that is costumes, which is essentially what the sprites look like, and any sound effects that you plan on using. And then on the far right hand side we have the actual area where you will construct your programs. This is Scratch 2.0. In January 2019 MIT are supposedly going to be releasing or unleashing Scratch 3.0, which looks like this. It's not hugely different. Broadly speaking, it's just been flipped. Stage area now is on the right hand side. Some of the options for your sprites are kind of here immediately visible rather than having to drill into it. Your flags are in the same place. Well, they're next to each other. On the left hand side, the area for your code is this big space here. The different categories of code now are over here on the far left rather than in the middle here somewhere. The code and the costumes and the sound effects are basically the same. It's not hugely different. Don't get too concerned by it really. Once you've come to understand and are fairly confident with Scratch 2.0, Scratch 3.0 is just the next logical evolution from there. So let's have a look at some of the terminology you need to know and be able to teach year one. So an algorithm is just a stupidly complicated name for a very simple concept, which is a sequence of steps. That's all an algorithm is. Whether it be the steps that you follow to put together a wardrobe badly, or the instructions you follow to build a Lego kit, or the instructions you follow to build a Hadron Particle Collider, or even just directions to get to a certain place, getting dressed, making a sandwich. All of those things are just sequences of steps, and that's all an algorithm is, a series of steps. A variable is really just a piece of code, the value of which can be changed. Literally, they are variable, they're changeable, they can be changed. So, for example, in Scratch, this piece of code here means that when we run it, Scratch the cat will move 10 steps. But this is a variable, so we can change it to 309 steps. 30 is what I was aiming for. Decomposition basically means taking a large problem and breaking that problem down into smaller pieces. So take the game Guess Who as an example. Your initial problem, the big problem you need to try and solve, is to try and work out which character the other player has chosen. That's a big problem. So what you do is you break that problem down into a series of manageable steps by taking a series of guesses, eliminating certain other characters on the basis of gender and appearance until you're finally able to make a guess. And of course the answer invariably is Philippe. So block code or block-based programming, or whatever moniker you want to give it, is essentially this. Scratch is as good an example as any. It is literally putting blocks together to create a program. It's become really, really popular since kind of computer science took off as a subject a few years ago. Well, took off again as a subject a few years ago. Scratch is just one example in which you use blocks to create a program. In Scratch, of course, you're creating blocks vertically. In something like Kodi that you can see now, exactly the same principle. The only real difference, apart from the visual aesthetic of it, is that you're creating horizontal blocks instead of vertical blocks. But even then, you're still kind of creating vertical ones. Sprites are basically any computer graphic that can be manipulated on the screen. Broad strokes, most people would think of it as being a character in a game. So Scratch, for example, would be a sprite. Whee!